Today we're going to take a look at a new topic, and that is the topic of closures. And you might already have seen or even used closures in your own Swift code, but today we're going to take a more holistic approach to understanding them. So at first, why are we dealing with closures in the first place? So it's important to note that closures are an essential part of the Swift programming language. The Swift syntax facilitates usage of closures and even encourages you to use closures where possible. So it's really important that you know what closures are, what problems they solve, and how they can be used. And furthermore, closures are a very important programming technique in general, and you'll actually find similar features in most other modern programming languages. So languages like JavaScript, Python, Ruby, they all have similar concepts as closures, and even Java introduced the concept of closures in Java version 8, and there they're called lambdas. All right, so for today's lesson, there are two things that we really are going to cover, because these two things are the key to understanding closures and how to use closures. And the first thing of this is we want to learn and see what it means to pass functions as arguments into other functions. So once we understand this idea of passing a function as an argument into another function, we can start talking about closures. But really, it's important to understand this idea before you can even start thinking about what closures are and how they can be used. So let's start with the first topic, passing functions as arguments into other functions. And before we really dive into that, we need to take a step back and really understand what it is that a function is made of. And so let's take a look at the anatomy of a function. So here we have an example function. It's a very simple function that takes in two integer arguments, value 1 and value 2, and the function adds the two together, computes a result, and then returns this result. So it's a very simple function. Let's take a look at the major parts that this function is made out of. So here on the one hand, we've got the function signature, and the function signature encompasses the name, the argument list, and the return value. And then we've got the function body, where we can put the implementation, so the actual functionality of the function. Let's take a closer look again at the function signature, actually. And here, as I said before, we basically have three parts. We've got the name of the function, we've got the argument list, and we've got the return value. And this really is all the information that a caller of the function would need in order to use this function properly. So if some class or some object wants to use this particular function, they have to know the name so that it can be called. They have to know what arguments this function takes, and then they have to know the return value or the return type in order to do something with the result of the function. So this is what a function signature looks like. And now I want to recall what calling functions look like. So the idea of calling a function. So here again, we've got the same add function, and we're computing the result. And please notice that the underscore in front of value 2 is still the old Swift 2 syntax. In Swift 3, the underscore is not required anymore. All right, so we've got the same function, and then we've got two exemplary calls to that function. The first one takes two numbers, and then the second one takes the same numbers but using quotes. So which of these would be the right call to the add function? It would be the first call, of course. And the reason for that is because the add function, as defined above, takes as argument two integer values. And 2 and 3, written like this, are integer values. In the second call to the add function, we're actually passing in the arguments as strings because we've got the quotation marks around the numbers. So this call actually wouldn't be accepted by the compiler, and the compiler would complain with the message that it cannot convert a value of type string to the unexpected argument type int.